Hello, welcome to today's class. All right, we are still looking at number bases, and this is another random question on number bases. We are told if 231 base 4 times 10101 base 2 equals to m base 6, find m. All right, so we have questions here. This is the number in base 4, number in another different base 2, a different base 6. So the approach here is to convert each of these to the central base, which is base 10. After which you convert them down to base 6 so that they will now be similar bases. Then you multiply these guys, you have the value of m. Alright, so let's start. This will be to power 0, so you already know, to power 1, to power 2, to power 0, 1, 2, 3, 4. So that will be 2 times 4 to power 2 plus 3 times 4 to power 1 plus 1 times 4 to power 0. Then there's a times there. Times 1 times 2 to power 4. Remember, the approach is always the digit times the base, then raised to the power on the digit. It's only the base that will be raised to the power on the digit. Then whenever you have a digit that is 0, just keep it because it's going to give you 0 at the end of the day. So what you just do is skip to this next significant digit, which is 1 times 2 to power 2 plus the last one now, 1 times 2 to power 0. So that will be equal to this m to base 6. Equal to m to base 6. So what we have done here is that with this linear method already, we have converted this to base 10. What we are going to have will be this in base 10, no more in base 4. Because we use this method to convert a number from any base to base 10. I call it the linear method. So what we are going to also have here will be this. It's no more going to be in base 2, it's now going to be in base 10 here. So let's do the multiplication. First square is 16. 16 times 2 is 32. Plus 4 to power 1 is still 4. 4 times 3 is 12. Plus 4 to power 0 is 1. 1 times 1 is 1. Right? Then times 4 to power 4 is 16. Sorry, 2 to power 4 is 16. Times 1 still 16. Plus 2 squared 4. Times 1 still 4. Plus 2 to power 0, 1. Anything raised to power 0 is 1. So 1 times 1 there is 1. So these guys are now in base 10. But the m is still in base 6. So we add this up, we have here 45 times, what would this give us? 21 equal to m base 6. So what we do now is convert these guys individually to base 6. This 45 base 10, this 21 base 10. Convert them to base 6. So let's see. Remember, when we are converting from base 10 to any other base, we use the table method. So if we use the table method on this, it's going to be something like this. We have 45 here, we have 6 here because we are converting to base 6, right? So that will give us 6 into 45. 6 into 45 is 7. Remainder 3, because 7 times 6 is 42. So 6 into 45, 7 remainder 3. So bring it down 6 again. 6 in 7 is 1. Remainder 1. 6 in 1 is 0. Remainder 1. So our answer there is 113 base 6 now. It's now in base 6. Then this times, because we are going to do the same for this. So we convert this 21 also to base 6. Right? 6 in 21 is 3. Remainder 3. 6 in 3 is 0. Remainder 3. I told us in the previous class that when you know the end of your division is when you have same numbers either diagonally like this or diagonally like this. So this shows the end of our division. Once the number cannot go here to be 0, remain at the same number. So here we have 33 base 6. So we are now having 133 base 6 times 33 base 6. This is a base, so it should be written very, need to be very small. Then equal to the m base 6. Equal to the m base 6. So what do we do at this point? This is what we do. We take these guys and multiply them. This 113 and 33, since they are both in base 6. So when we multiply them, what we have in base 6 will be the value of m, because m is already in base 6. Alright, so how do we do that? We can come here and continue. Let's just manage our board. Come here and put here 113 base 6. It's in base 6. Let's not forget that. Then 33 also in base 6. Do this. Alright. Now remember I said, now that we are dealing in base 6, whatever multiplication we do, whatever addition we do, we should take note of the result. If the result is up to 6, that is one bundle, move it to the other side, and whatever is left we drop. So now if we first multiply, remember these are bases. Let me just remove them to avoid confusion. We already know that these two numbers are in base 6, base 6. So our multiplication now is done in base 6. So 3 times 3 is 9. And if you look at 9 items, for instance, 1, 2, 3, 4, 5, 6, 7, 8, 9. 6 of them are giving you a bundle. Remember, whenever we are dealing with particular base, when you have up to that number, you move it up as a bundle. So what is left here? 3 is not up to a bundle. So it is the 3 you are going to drop. Alright? So we have that understanding now. That's how we are going to be doing it. Okay, so now that's 3 times 3 gave us 9. So inside now we are going to have 6 as a bundle, 3 remains. Alright, and whenever you are moving that bundle to this side, you are taking it as 1. Alright, so 3 times 1 is 3 plus 1, 4. 3 times 1 is another 3, drop it there. Right, so we are going to repeat the same thing, because since it's 3, whatever this multiplied to give, this also multiplied to give the same thing. So you put it, but this time you just skip one place value, start from the 10 digits. So it's going to be 3, 4, 3. So this is the part you do your addition. Now even in the addition part, we still pay attention to the fact that we are dealing with base 6. So whenever we add anything and it's up to 6, move it up as a bundle. Whatever we left that's not up to a bundle is what we drop. Alright, so let's start. There's 0 here. So 3 plus 0 is 3. It's not up to a bundle. It's not up to 6 items to give us a bundle, because we said in this topic that the number of items that form a bundle tells us the base we are dealing with. In other words, number basis simply means the number of items that form a bundle. Alright, so 4 plus 3 is 7, and in 7 we are going to have one bundle, then 1 will be left. Carry 1 over. 3 plus 4 is another 7, plus the 1 we have got over, 8. So in 8 we have one bundle, 2 will be left. So this will come, the one that we have carried, one bundle, will come and add up to this, and it's going to be 4. 1 plus 3, 4. So this is the answer in base 6. This is the answer in base 6, which is equal to this same m in base 6. So you can come and say, therefore, your m equals to 4213. This is the value of our m. So this is how to solve this kind of a problem. Alright, in number basis. You can find this in theory, in you can even find it in JAM. Of course, JAM is always OBJ. You can find this kind of a question there. Alright. We're looking at multiplication and division of number bases now. We are done with addition and subtraction, and of course we've also solved some random questions. So if we are given, evaluate 2115 base 7 divided by 12 base 7. 2115 base 7 divided by 12 base 7. Now the approach to this kind of a problem is for us to of course convert both of them to base 10. We convert both of them to base 10. we do our division in base 10, what it gives us, we convert it back to base 7. That's the easy way to go about it. Alright, so let's convert this to base 10. This will be to power 0, to power 1, to power 2, to power 3. This will also be to power 0, to power 1. So we have the 2 times 7 to power 3, right? Plus 1 times 7 to power 2, plus 1 times 7 to power 1, plus 5 times 7 to power 0. Now divided by 1 times 7 to power 1, plus 2 times 7 to power 0. I hope we can see the board clearly. Alright, so we have here 7 times 7 times 7, that's 7 to power 7 to power 3. Then of course times 2 gives us 686. Without wasting time, let me just give you the figures. 686, alright, plus 7 squared is 49, times 1 is still 49, plus 7 to power 1 7, times 1 is still 7, plus 7 to power 0 is 1, times 5 still 5. With this we have converted them to base 10 already. So what we are going to have here, when we sum it up, it's going to give us the number in base 10. The same thing here. So here we have 7 times to power 1 is 7, times 1 still 7, plus 7 to power 0, 1, times 2, still 2. So we have here, when we add this up, we are having, let me just give us the figures so we don't waste time. 747 base 10. 747 base 10 plus, we add this up, we have 9 base 10. So the approach now is for us to divide 747 by 9 to be equal to 83 base 10. Now this 83 base 10, we have to now convert it back to base 7 because the initial question came in base 7. So we are expected to also leave our final answer in base 7. So we have to come back and convert 83 base 10 to base 7. So this is what we have. We have 83 here, we have 7 here. 7 in 8 is 1, and that 1, you put that 1 here, it's 13. 7 in 13 is 1 again, the remainder 6. 7 here, 7 in 11 is 1, remainder 4. 7 in 1, 0, remainder 1. So our final is the final division. So we can now come back and say our final answer there is, take the answer from bottom to top, 146 base 7. I remember what we said when we started this topic, number bases. We said that if a number is in a particular base, all the digits of the number must be less than the base. So that's our answer. So we can come and say, therefore 2115 base 7 divided by 12 base 7 equals to 146 base 7. Alright, I just want to put that there. Alright, let's look at some standard values. Standard values meaning when you have a particular number in a particular base and you are converting to a particular base, what it's going to give you is fixed. So if we have the first standard value, we have 0.1 base 2. It's going to give us 1 over 2 base 10. We have 0.01 base 2. It's going to give us 1 over 4 base 10. We have 0.001 base 2. It's going to give us 1 over 8 base 10. And so on and so forth. So as the 0 increases by 1, the denominator doubles. So the next thing, of course, you can predict now. If we have 0.0001 base 2, the answer will be what? 1 over 16 base 10. We have 0.00001 base 2. The answer will be 1 over 32 base 10. So we can actually prove any one of them. We can use this to be our, remember I said from any other base to base 10 is the linear method. So if you have to use one to prove why the answers are like this, or let's use the second one to prove it. We have 0.01 base 2 and you are converting it to base 10. Alright, you're going to have this to power 0 on this side to power minus 1 to power minus 2, because this is the unit digit. When you plot the unit digit to this other side, the powers are in minus. So this will now be 0 times 2 to power 0 plus 0 times 2 to power minus 1 plus 1 times 2 to power minus 2. Remember I said any digit that you have zeros, any digit of 0 will give you 0. So we'll leave those side and concentrate here. So that will be anything multiplied by 1 is still that thing. So that will be 2 to power minus 2. And 2 to power minus 2 from our indices is going to be 1 over 2 to power 2. And 2 to power 2 is 1 over 4 base 10. So you see, that's what we call them standards. If you work out these ones, this one you are going to also have in their base 10. So again, let's solve some random questions under some of those standard values I gave you. Let's say we are given 3 over 4, alright, base 10. And we are asked to convert it to base 2, the binary. Remember, when we wrote 0.1, for example, base 2 to base 10, it was 1 over 2. So that also means that 1 over 2 base 10, alright, 1 over 2 base 10 will also give us 0.1 base 2. Of course, we can also reciprocate it. So we are going to be applying the standard we've just looked at now to solve some problems. Now this is not in the standard we're given, but we can break it down. So 3 over 4 can be broken down into 1 over 4 plus 2 over 4. Right? They are all in base 10. We are trying to convert it to base 2. So that will give us 1 over 4, plus this can be simplified into 1 over 2, both in base 10. So that will be equal to the standard we had for 1 over 4 was 0.01 base 2, plus the standard we had for 1 over 2 was 0.1 base 2. So by the time you had 0.01 to 0.1, you add it up, you are going to have 11.0, that's 0.11 base 2. So our final answer is 0.11 base 2. This is how to solve this kind of a problem. Alright.